see us, if I did this the way I like to do it, you'll just see the Excel spreadsheet. So it'll be a little bit bigger. And hopefully the audio is clear. That's why I switched softwares. The Google Meet recording looks pretty good, but the sound is terrible. So you can't hear what anybody's saying. How are you doing? Did you make any progress with just the notes I gave you?
I was able to go back and I fixed, what was it, question 2?
Mm-hmm.
And fixed that. And then I kind of have maybe an idea on chapter 9, question 2, but also it could be completely not the right thing. I didn't do any work with it, but I just have an idea maybe.
Okay. Well, we'll pick some stuff and we'll just work on it. Okay.
Okay.
We'll see if anybody else shows up. The mind-blowing thing every time I teach this course, first, just like I said in one of the videos, I don't think this class should ever be taught online, especially not if it's asynchronous, and doubly especially if it's in the half semester format.
Mm-hmm.
It's a lot at first until you get the hang of it, and all of a sudden you'll be like, oh, this isn't that bad. But it blows my mind. Every semester, half the class doesn't come to any of these calls until it's so late there's no way to get through the homework. I'm like, oh,
Yeah.
you did it to yourself.
Yeah.
Oh, okay. Well, so can you see my Excel screen now?
Yes, I can.
All right, let's, so your location problems you did just fine. I don't think we need to do
Yes.
those. All right, and then we've got chapter 9, exercise 2. I put some tips in there, and you just told me, but this is the kind of week I'm having. I already forgot exactly what you said. Did that get you all the way to the end, or do you want to look at this one?
No, if you don't mind looking at this one.
Okay. More than happy to. And all of these problems, there's a few different ways to skin the cat. Just a little bigger for myself. You can probably see it fine. But I've had just enough birthdays now that can't always see the way I want. Okay, so I went ahead and set up the data table on this. And a lot of folks make some of these things harder than they need to be. But that's okay. That's what we're here to talk about some things. So I'm going to skip way down here on the page and make a spot to put my decision variables. Okay, and I'm kind of simple about how I like to do some of this stuff. We know we're going to have 3. So we've got the question basically says, hey, what mix of fertilizer A, B, and C, which has these contents and price, gets these minimum quantities of minerals at the lowest price? Okay. So the thing I'm trying to decide is, so I'm going to come down here. Personally, I think it makes life easier if I even highlight this. As many Excel models as I've built through the years, and then just label this in a clear way. See, I want to do amount of fertilizer A, amount of fertilizer B, and amount of fertilizer C. I'm going to change my alignment here so that it's nice and pretty. Okay, and this is what I want to find out. Now, I don't know what range I should put in here for dummy variables, but so that I can see if the formulas are doing anything, I'm going to at least put something in there. Okay, so I want to just put a 1, 2, 3 in there. Okay. So now, when you're using Solver, don't think about solving the problem. Think about, okay, I just let Solver know that I'm going to let Solver change these 3 numbers to end up with the best possible outcome. Okay, so somewhere on this page, I'm going to have a total cost, right? Well, to lay this out in a way that makes some sense, here's where my prices are. So I'm just out of curiosity, I'm going to say total cost, and I'm going to say that this is the thing I'm trying to optimize. Let's go. I'll go light blue. I feel like light blue today. Why not? Even though I'm in my favorite ratty green sweater. There's no way I could wear this in public. You should see how stretched out it is. It's fantastic. So you get a total cost over here. Next, to solve the problem, all I'm going to do is build formulas that create a relationship between my data and my decision variables. Okay? So, and partially because I've worked this problem 52 times, I like to pick a way to stay lined up with the columns. So I put my total cost right under my price. So I'm going to make a total nitrogen cell. I'm going to make a total phosphorus. I'm going to make a total potash. Okay, so I'm going to end up with some formulas in these three cells. Again, personally, I like to stop and take a minute and make this layout look decent. Okay, it doesn't seem like a big deal to a lot of folks, but these are tiny models we're building. I'm not sure what direction your career will take you, but this model is going to end up being 10 columns wide and 20 rows deep. Fantastic. I worked on some models with my financial analyst a few months ago that was 5,000 columns wide and 150,000 rows deep. Okay, as long as you're systematic in how you build it, it can give you great insights. But even these little models can. So now I've labeled this. Now I have to tell myself, okay, how do I calculate this? Well, this is where you can approach this a couple of ways, and I'm going to make sure you get your intuition about this. So if I said the amount of fertilizer A times the amount of nitrogen in fertilizer A plus the amount of fertilizer B times the amount of nitrogen in fertilizer B plus the amount of fertilizer C. Did I drag that? We did. Let's start over. Sometimes I fat finger it. Okay. So the amount of fertilizer A times the amount of nitrogen in fertilizer A plus fertilizer B times the amount of nitrogen in fertilizer B plus fertilizer C times the amount of nitrogen in fertilizer C. That'll give me the amount of nitrogen put in. So by saying 1, 2, 3, and this problem actually has one little curveball in it that I never take points off on. This is basically in thousands of pounds, 1,000, 2,000, and 3,000. Gives me 85 net result on nitrogen, which is way more than I needed up here. So depending on how you set this up, you get a fractional answer. So that's one way to look at it. The faster way, oh, and are you one of the ones that uses a Apple MacBook?
Yes, I do have a MacBook.
So I'll point out one thing that's important. So the faster way to get this same formula I just built is to use the formula sum product. And then all I have to do is highlight the array, comma, highlight the second array. So this time it's phosphorus, and it works exactly the same way as that formula I just built. Okay? Now here's the watch point for Excel on MacBook. In theory, if I had an array that was 7 tall and 1 wide, I could multiply it times an array that was 1 tall and 7 wide. Only works in Windows. It's a glitch in MacBook. So if you'd use the sum product, and I'll just hit that function so you can see the highlighted, not only does the array have to be the same size, it has to be the same shape. If one is vertical, they both have to be vertical. But you can use the sum product as long as they're both vertical or both horizontal. Yes, I have written to Microsoft saying it seems like a simple fix. And here's the crazy thing. Even if you go to the trouble of installing a Windows Parallels work machine on your MacBook and install Excel for Windows on your MacBook, it still doesn't work. So just be aware this is one of the glitches. Also be aware that for some reason Excel on MacBook, if you pick dummy variables that are too far from a possible solution, it will not get all the way to the solution on one click of solver. So if it looks fishy, run solver again and see what happens, or change your dummy variables and run solver again. I don't take off points if it's obvious that somebody on a MacBook got stuck. But something Dr. Sibbins and I have talked about is we're thinking about making it so that if you take this course, you just got to be on a Windows machine. It makes your life easier. Now, when I teach this course, I specifically teach it from a MacBook so I can try to be helpful. So that formula works. Now, I can just copy it across. But first, I have to make sure that my decision variables doesn't slide whenever I copy across. I end up with absolute references. So I want to make sure it stays in column C. So I'm going to do my $sign just on the decision variables. And then I can do this. And in this case, I don't want to change my formatting under total cost. So I'm going to do the edit, paste special, and I'm going to paste just the formulas. And now we hit this, okay? Now I'm going to change this formatting so it's in the same units. I'm going to leave it where the pennies show, okay? And we basically have now built our model. We've got enough to run Solver now. We've calculated how much nitrogen, phosphorus, and potash it's trying to put in. We know what our constraints are. I must have at least these. These are my minimums. And then I want to minimize my total cost. So that's all you got to do. Oh, my screen recorder thingy is in my way on my menus. All right, so now I can click Data, go to Solver. I'm going to reset all so we can populate this whole thing. Okay, so my objective is that total cost, right? So it's right here. Click on my total cost. I want to minimize it by changing these 3 cells. Fantastic. I'm going to add a constraint. I don't know why it does this sometimes. Okay. Now, this is where some people make their lives a little harder than it needs to be. So it's shaped differently. I don't know if this will work or not. So you can highlight a whole array and say must be greater than or equal to. But since I'm on a Mac, I'm going to play it safe and say nitrogen must be greater than or equal to my nitrogen. Add. Then I'm going to say my phosphorus must be greater than or equal to my phosphorus. Add. My potash must be greater than or equal to my potash. Click OK. It looks like we've got everything. We want to minimize costs by changing the amount of fertilizer, and we are subject to 3 constraints. I say solve. Click OK. That looks fishy to me. I'm going to give it some more decimal places. And it doesn't look fishy anymore because I happen to know that's the answer. So this is basically in thousands of pounds. Total cost $13.76. You don't have to use any of fertilizer A. And that's one of the things a few students have a hard time getting a grip on, especially in the mixing problems and in the make or buy problems. Sometimes the answer for one of your source materials is 0. It's okay. I just wanted to end up with the cheapest blended version I could get. And there's your answer. So do you have questions on that one?
No, that makes sense.
Cool. Yeah, and what I want you to do, I'll even send you this file when we're done. Here's the upside of people that take the time to show up for a tutoring session. It makes it so you can get 100 on the exam because the exam problems are identical to these. You just get familiar with it. I'll send you this work file when we're finished. I'll post the video on YouTube and send you the link. But what I want you to do is take the time to build your own file, copy it again, and put some comments in there. So after you did all this stuff, just type a few things in about what you're interpreting, what you think you see the model doing. Because on the exam, I grade the comments a lot more than I grade the model itself. Because you can run out of time on the exam. So the first exam, I think I give you 4 problems, and I only give you 2 hours. And depending on if you kind of get hung up on laying your page out, you can run out of 2 hours pretty fast. Dr. Newberry, the dean of the engineering school, and I are the only 2 that teach this course at this point. And we'll send our exam to each other to test it out. And what we've decided is if it takes one of us about 25 minutes to do it, it's 2 hours. It's pretty tough on the master's student. But we've been doing this longer.
Yeah.
And Byron's a great dude. Let's look at exercise 4. And there's, on all of these, there's always a couple of ways to approach laying things out. And I'll show you a couple of ways on this, and then when you rework it, you can do it whichever way that you would like.
Okay.
So this one stumps people for some reason. It's the same problem we just worked. It's a mixing problem with constraints. In this case, it's laid out vertical, okay, where the one we just did, whoops, was laid out horizontal, okay. So I've got items, I've got total amounts of different things I want to end up with in there. But in this case, it's money, okay? Whoops, that's the other one, 7A. So we're gonna lay it out in a really similar fashion. We've got certain constraints that we've got to meet, and we're gonna do some decision variables, okay? I'm gonna continue with similar approach to what I just did, okay? I'm gonna make a section for decision variables. And I'm going to go ahead and highlight them. I've got 5 bonds that I want to know how much of each bond do I put in here in order to get the results I'm looking for. So I'm going to highlight that. Oops. Oh, I've had a week, I'm telling you. Oh, I'm calling them letters, and it's 1, 2, 3, 4, 5. Now my OCD will not let me continue, just so you're aware. Even though I'm having a day, I got to fix it. Okay. I'm going to change this to be right aligned. There we go. So that's going to be my decision variables. Okay. Now, in this case, the amount of the bond, there's 2 ways to approach it. You could put dollar figures in here and say that has to total up to this $1 million. You can put percentages in here, and you can then say that must total up to be 100%. They both work just fine. Okay. For fun, I'm going to do dollars this time. Usually I do percents, but this works out fine either way. And I'll show you a couple of ways to approach this. So I'm going to say that these are now going to be formatted as dollars. I don't care about having pennies in here, but put 100,000, 50,000, 500,000, 100,000, 25,000. Okay. I know that by the time I'm done with this problem, one of my constraints is that this must total up to be $1 million. Okay, it's okay that the dummy variables don't. Okay, just for fun, because I'm wearing my cool green sweater, I'm going to highlight my constraints, calculated constraints in green. Okay, so I know when I build the solver solution, this constraint must equal this available investment. Okay. Now, I've got to start thinking about, all right, how do I calculate the blended result? So if I have some mix of these bonds in there, I'm going to have a blended result. My personal opinion is the easiest way to do this is to show all your work. Don't hide anything inside of a long formula. Okay? So now I'm curious, okay, in order to know what my percentages are of each one, because multiplying a percent times a percent is an easy way to get to a blended result. And I'll show you what I mean. So I can say that this amount of investment that I put in here is some percentage of my total investment. I'm going to format that as a percent. I show 1 decimal place. And then I could say, I've got my expected return, that I've got some target I want to end up with the expected return. So it says my worst return allowable is 7.2%, and I want the best possible return. So that's the thing I would want to maximize, right? So a few ways to approach this. I could then say that this percent of bond A times the expected return of bond A, that's the contribution. I didn't multiply, I fat fingered it. That times that. That's the contribution of return that you would get, is by percentage. Another way you could do this is right here in the formula, and this is how a few students confuse themselves, is you could say, oh, hold on. Go away, teams, I don't want you right now. All right. That this item divided by my total investment times the return from that part of the investment gives me some expected return. But that's hiding more things inside the one formula. So what I think is easier is to say percent of investment. Okay. Fix that layout. And I've got my expected return already there. And since both that formula and the other one are vertical, as long as I make sure this reference doesn't slide down the page, I can just do this, okay? And then if I take a sum of each of these contributions, that's what I ended up with. So if I picked these dollar amounts, 10.63% is my blended return from all the bonds. Did you follow that?
Mm-hmm.
Okay. It's that straightforward, okay? Then I've also got the question of worst return, because I've got a constraint that says, hey, no matter how good the upside is, I want to be protected from the downside a little bit. I don't want my worst return to be any worse than this 7.2%. So it's the exact same exercise. I'm going to do my percentage of the investment times my worst case return. Okay? And that's the contribution of that one. Okay? And you can kind of see some things here. If I had seen this coming, I could have built that formula too, and built that formula too, and built that formula too, and copied them all at once. But it's okay. You don't have to see it coming. Okay? And once again, just copy that. And this sum I can copy. In fact, I'm going to label, those are my totals. Okay? This is what I'm going to want to maximize in a minute. I get that cool blue. We're going to make the cool green sweater for my calculated constraints. Okay? And then I've got a duration as well. Same thing. My percent of my investment times the duration of that individual bond gives me this. This is not a percent. This is in years. So I don't care about that many decimal places. I'm going to copy that down. Copy the blue one so I don't have to keep reformatting. Oh, and it wants to be a percent, which I don't want. There we go. So 6.1 years is what it came up with. Okay, that all makes sense to you?
Yeah.
Yep. And you can do it just like I did here, or what does work just as well, down here I'll show the other approach. Since the arrays are shaped the same, I could choose to do sum product, comma, highlight. And you can see I get the exact same answer as I got here. 10.63% or 10.63%. Whatever you're comfortable with. It does not matter. Okay? Just so you'll have both formulas to look at when I send you the file. There we go. So you could look at it and see, the parallels, So here I broke it all out. You could even do the version where you do this one times that one plus the next one. Doesn't make any difference. Now, what else do we have as a constraint here? So I can do it inside of Solver, but there's one more. So it says the maximum of any individual bond is 40%. So these calculations, you can already see that one of the dummy values I put in was 64%. It's going to violate that 40% maximum. So you can, inside of Solver, just highlight all of those and say less than or equal to this constraint up here. You can also, if you prefer to, put it out here in plain view. Okay. I can tell you, if it's a bigger model, I prefer this. Okay. Because I highlighted these the wrong color. There. Constraints are cool green. Because if it's a big complicated spreadsheet, inside a solver is not the place to highlight a whole bunch of stuff. Okay? So I know that my total investment is this. My maximum investment is this. I didn't lay this out very well to be labeled. So I think it's smarter to do this. Okay? And that just makes it easier to troubleshoot your spreadsheet later and find out if you got something funky going on. All right, you comfortable with this for me to populate Solver now and see what we get?
Yeah.
Okay. Data, Solver, let's reset all. And so you're aware when you email me your files too, Solver stays populated by tab. So it's easy for me to open up Solver and see, whoops, they accidentally tagged something wrong. It's also easy for me to see if somebody used AI to build the spreadsheet because Solver will be blank. I'm smart. I know how this works. Okay, so here's my objective. And we could have done this two ways. Well, I'm going to show you one more double thing. Okay, we can choose to maximize this expected return. We could also say that we've got a dollar return on our investment. Make this that cool blue color. And I could say that this is our total bonds times our expected return. Okay? And then format that as a dollar. Okay. Then inside of Solver, whichever one you chose, you then pick one. Okay? I like working in percents. Some people like working in the dollars. So I'm going to set the objective at this expected return right here. Okay? And I want to maximize it by changing these cells. It's these 5. How many dollars am I going to put into each one? Subject to the constraints, and we've got a few. Oh, come on up here, constraints. So I'm going to start by constraining the dollars, and I'm going to say that this total investment must equal this available investment. Okay. I'm going to add another one. And I'm going to say that this maximum per bond must be less than or equal to this 40%. Great. Add another one. And say that my worst case return must be greater than or equal to my worst allowable. And while this one's visible, always, and I said this in the lecture, but I'll say it here as a reminder, always put your calculated value in the cell reference portion and your scalar value in the constraint portion. So we calculated this 7.05, and then in this constraint, we typed in this 7.2. The one that's calculated on the left, the one that is a typed in constraint on the right. Solver can do it both ways, but if you're not consistent, you will get confused. And it is easier in Solver to accidentally create a circular reference if you do it the other way around. And Solver will get stuck sometimes if you do it the other way around. Okay, I'm going to add one more. And my duration, my years, must be less than or equal to 6 years. Whoops, that's not my 6. that one. There we go. All right, now I got E19. Click OK. All right, so I've got my total investment, I've got my individual max, I've got my worst return, I've got my duration. I want to maximize my percent return, and by changing D25 to D29. All right, I think we're good to go. We'll hit solve. Click OK. Interesting. And I don't think that looks fully baked. So I'm going to hit solver. Solve again. Watch, this is going to be one of those times that it's not playing nice with me. So I happen to know that's not the solution. So if you do this and it just doesn't calculate the right solution, but you've got it laid out correctly, you'll get all your points on the homework and the exam. Okay. I happen to know this doesn't look right, and even without having worked it before, I would think this looks fishy. Because it's not going all the way up. It's not butting up against the maximum duration. It's only butting up against the worst return. And my hunch tells me that if I run longer, it'll solve better. Out of curiosity, I'm going to put 100,000 in all of them. Oh, and it was also the total bonds was coming up wrong, wasn't it? So I'm just going to try a different dummy value set. Click solver. Solve. Still converging on it. So that's not an optimal solution. But like I said, if you worked it and you got this answer, it's great. And that's one of the things a few people have a hard time making peace with is solver is not perfect. Okay? Doing this type of thing only works well if you're already pretty close to the answer, and this is close enough for the point of this exercise. Now, what I happen to know if I did this as percents instead. Oh, I got to move more stuff around than I expected. Oops. I'm telling you, I'm having a day today. All right, if I do it this way, let's see what it does. I'm just curious. So this time, without doing it as dollars, I'm doing it purely as percents. So solver, this time my objective is my expected return. I want to maximize it by changing variable cells. Change these. Oop, should have reset all first. this must equal 100%. Add this must be greater than or equal to 7.2. Add this must be less than or equal to 6. Add these must be less than or equal to 40. Okay. Solve. Yep, and that's the most optimal answer. So I don't know why solver gets stuck sometimes when you build algebra a certain way. I've sat down with how the formulas are structured, but something about the choice of doing it this way over here, made it so that it didn't want to add up the way that I wanted it to add up. But like I said, whichever way you choose to do it, as long as the model makes sense, I won't take any points off on it. I'm familiar enough with it, I can see, oh, the model didn't converge because of this reason. I think I give you guys a distance problem, like the one you did that had 2 locations to optimize. At some point I give you all one with 3 locations to optimize. Depending on which dummy variables you put in, there's 2 solutions. So it's on my to-do list to never give that homework problem again, but I haven't written a new one yet. Okay, so other questions on this one? Hopefully showing you that it didn't quite optimize, didn't confuse you too much. But you can see now what ended up happening is my worst case return is better. My best case return is better. And I used my full 6 years. So for some reason, my assumptions over here, it liked the worst return constraint better, which I don't quite get. Oop.
Okay.
So I'll do my million here. Times 10.85. So this is the official solution.
Okay.
Cool.
Yeah.
All right. So even though I like giving freebies, so you got 2 freebies there. Just copy those back out, and you'll do great on those ones. For the make or buy one, I actually don't want to give you a freebie. I want to work another problem that's almost just like it, and let you try to set it up yourself.
Okay, and I've done most of that one.
Have you?
Besides, when it's asking the effects of increasing it by 10%, and it's only increasing the fabrication.
Mm-hmm.
But how do I only increase that without increasing the other? What's underneath?
So I would just go in and change the assumption. See here, this is my similar problem. So fabrication was the first row in the other one, it was here. Yeah. I'll just do this. So you already got this then. Oh, I'll do it this way. What is wrong with me today? I'm telling you. I didn't even fly in late last night. I flew in yesterday morning and went to the OC Associates dinner last night. Create a copy and tutoring examples. Put it before problem 7A. Okay. So you will get one. Okay, so, and your layout may look different than this, but it's no big deal. Okay. What is it doing here? There. All right. Oh, that's why. Okay. So did you do something similar to this? Did you get answers kind of like this?
Yes.
Yeah, so fabrication became your constraint. Of your constraints, it's the one that stopped you. I like adding this column, calling it slack. That's how much of each one was left over.
Okay.
The book doesn't give a tip like that, but again, in a small model, you could probably look at it and go, oh, look, this 2,000 hit the limit of 2,000, but this 3,300 did not hit 4,200, and this 2,100 did not hit 2,500. My fabrication is my limiting factor. If you had a column like slack, especially in a great big spreadsheet, oh, here's the one that went to 0. 0 is easy to spot. So I like doing it that way. So let's do this. I'm going to move it for copy. Put it before this one. Boink. Where did it go? Oh, I just moved it. Create a copy. Oh my gosh, I'm telling you. I'm going to rename it. See if I can rename it more efficiently this time. Instead of fumbling around like I did. So part B, you're saying, is when it says to change it by 10%. All it's looking for is for you to change this number by 10%. Okay, so there's a few ways you can get in there to do it. I double clicked and I'm going to turn it into an equal sign times 1.1. Now I got 2,200 hours available. It's that simple. Okay. Now, when I've done something like that in a sheet, I'll either highlight it or bold italics it, something so I know I changed it. So this one's now changed. I go to Solver. Let me make sure it's still set up correctly. Yep, I'm going to try to maximize my profit by changing E16 to F17, E18 and F18. Yeah, must equal my demand. And that's one thing I would call out is you want it to equal the demand, not be less than or equal to demand. Depending on how the problem's worded, if you pick the other one, I'm not taking points off, but it might run a funny model. Then see here, H17 must be less than or equal to F. So my buy limit is in there. And then my 3 constraints. So in this case, I put all 3 of them together. My H5 to H7, these 3, must be less than or equal to my D5 to D7, these 3. So it'll pick up on this that I now have more fabrication time. I click solve. Okay. And the interesting thing, I click OK. Now I've got a new solution. I bought a little less. I made a little more. I made more money, right? But what's the interesting observation on this one that I would want somebody to put notes about?
The slack, yeah.
Fabrication is still my constraint. Okay. I hate it when I don't like that it's giving me a number like that. Stop doing that to me. Oh my gosh. There. So, and it will try to give you things that are near 0. I don't think there's a homework problem this term that you set the integer restriction. But so now you make a little more money. What's the next part of that problem? Line 7.
Or how much of a change in the fabrication capacity will the pattern persist?
Yeah. So in that case, I'd like to see you just noodle with it, until something else becomes your constraint. So B technically was describe the qualitative pattern. So this was rename. This was A and B, where just interpret the model. I hate the way this book says things sometimes. What's the qualitative pattern? Well, the qualitative pattern is I ran out of fabrication time. Great. Then here for question C, I added my 10%, and you would add a note in here, even with 10%, is still my constraint. And you might say something like, ooh, if I continue to add fabrication, I think shipping is my next constraint. So then for part D, how long will it persist? Okay, so I'll make another copy here. Create a copy for that one. That's not really what that one's called. Rename. So for part D, I had these notes in here, but this time I'm going to do something interesting. So yeah, it looks like I'm going to run out of shipping at some point. So to make this really interesting and find out when I would really run out of this, I'm going to change fabrication by a lot. I want to make a big number change. So something else for sure becomes a constraint. So I'm going to change it to 5,000 just to see what happens. Give it lots and lots and lots of slack. Okay. And then we go to data, solver. I'm going to solve it again. And yep, sure enough, now shipping is my next constraint. And I don't have to keep changing this one to figure that out. I know something. So I can say if I want to calculate my constraint, it's this crazy number I put in minus the slack that's left when something else became the constraint. So now I know at 2,500 is when fabrication would run out of steam, right? I don't even have to run solver. If you want to, you can just keep changing the number and run solver over and over again. There's no harm in that. And you might have had the intuition even to see it coming. But what you can then say is at 2,500 fab, shipping becomes the constraint. And something that might be interesting is to come down here and say, oops, my OCD is going to kill me if I don't fix that. Hey, over here, I thought $298,000 is the most money I could make, but 307 is it, okay? Formats. Make that dollars. This is my original profit. So I might be interested in saying, you know, what's my minus that. And a very good comment to add would be, you know, hey, I started at 2,000 is if I add 500 hours in fab, I can make 9,000 more profit. Because that's the real business question, right? Is I learned that fabrication was my constraint. How much does it cost me to add 500 more hours to fabrication? Well, if it costs me $50,000, I don't want to do it. If it costs me $1,000, I want to do it. So that's the size of the prize. So that's kind of how you think about this one. I think there is at least one problem on one of the two exams that has you solve it, identify the constraint, and then change that constraint. So it's just like this. But don't make it more complicated than it needs to be. Step one is you just change this by 10% and run it and see how you see the problem evolving. Okay. And that was kind of the point of that very manual break-even analysis I had you do in Unit 1 with the tractors, is to see, I've got a solution. Okay, what if I throw a curveball in at 200 tractors? Oh, I don't like the solution anymore. I only like the solution if I can sell more. What if there's another curveball at 400 tractors? You know, I forget the examples, but it's kind of where that is. All right, see, since you'd already worked part of this, you were spared from learning mixing on a soft drink company, but you know, that's what I get excited about. I don't know if you drink it or not, but most exciting news for me in the last month is Pepsi Cola buying Poppi. So we produce for Poppi on the West Coast. So Poppi doesn't own any of their own manufacturing. So these make or buy questions are central to what I do. I pitch at large companies like Coca-Cola, Pepsi, Dr. Pepper, Poppi, Olipop, Monster, Arizona Iced Tea. Hey, you don't want to make your diet version. You don't want to make this other one. We'll do those for you, and we'll do them cheaper than you can. And they offload those. I've spent the last 20 years of my career getting major brands to not make their stuff and let me make it for them. So, more than 20 years now. Started producing Gatorade in 2003. That was my first major brand that I pulled off and pushed into a different manufacturing setting.
Awesome.
All right. Any questions on that?
No, I appreciate you taking time and doing this
Yeah.
for me and working it out with me.
Yeah, and it'll click. So since you've spent time on this and you're going to look at this again, and we work through these, um, I'll take the diet soda example out. In Unit 2, you'll hit this problem. It's pretty tricky. That's okay. You'll hit it when you hit it. But it's loading a container ship. Just don't panic. It's a mixing problem. And it's a mixing problem that's almost exactly like the investment problem.
Okay.
You know, where on a boat do you choose to put the weight so that won't tip? It's 3 constraints. It's creating a blend.
Okay.
All right, cool. If you don't have any questions, then I'll clean this file up. I'll make sure the video captured, and I'll send all the links and everything to you. It takes a little while for the YouTube video to upload, so it'll be later today before I send you the link for the video. But I'll send you this Excel file the next 5 or 10 minutes.
Okay. Thank you. I appreciate it.
Super. Right on. Good luck tomorrow.
Thank you.
It's going to be cold.
It is. I know. I'm not looking forward to it.
I gotta admit, one of the few things I don't miss about coaching is being out in the weather. And I know we emailed about it, but the straw that broke the camel's back was we had a game that was particularly cold outside and windy, and half the parents of the U19 competitive team I was coaching are sitting in the car. They're not even out by the field. And we lost, and one of the dads did not like whatever he perceived I did at some point in the game. And I'm like, I don't get paid to do this. And I just stood out here in the cold and wind for 2 hours coaching your kid.
Mm-hmm.
Like, I am so finished after this season.
Yeah, that's awesome.
So now I coach jiu-jitsu instead. But
Yep. A little easier, probably.
yeah. Although we forgot to turn the heater on. That's where I was this morning. I had a private lesson. I took my private lesson from the 3-stripe black belt that I study under, and then I delivered a private lesson to a purple belt that I'm teaching, and ran back over here to put on my comfy sweater.
That's awesome.
Cool. All right. Well, I hope you have a good day. I'll send this to you.
Thank you. You as well.
Yep. Bye-bye.
Bye.